We're going to evaluate the integral of natural log of x plus square root of x squared plus 1. And we're going to use a technique of integration called integration by parts. Recall the integration by parts formula. The integral of u dv equals u times v minus the integral of v du. So we'll rewrite our integral as the integral of natural log of x plus the square root of x squared plus 1 times 1 dx. We have to select a u and a dv. So clearly in this problem u has to be natural log of x plus square root of x squared plus 1, and dv must be 1 dx. If it's the other way around, if dv is natural log of x plus square root of x squared plus 1, to go from dv to v we would have to integrate, which is what we're trying to do in the first place. Now to go from dv to v with dv being 1, v is just x. And now we differentiate natural log, which is easier than integrating it. So differentiating natural log of x plus square root of x squared plus 1, we get x plus square root of x squared plus 1 in the denominator, and 1 plus 1/2 times x squared plus 1 to the minus 1/2 times 2x dx in the numerator. Clearly we have to simplify du before moving forward. So du is equal to 1 plus the 2 and the 1/2 cancel, and we have x divided by the square root of x squared plus 1, and then it's divided by x plus the square root of x squared plus 1 dx. Now the common denominator here in the numerator, what I'm circling, is square root of x squared plus 1. So we can write this as square root of x squared plus 1 plus x divided by square root of x squared plus 1, further divided by x plus square root of x squared plus 1. And this looks way too complicated to continue, so we need to simplify before moving on to integration. Du is equal to, if you notice that these two belong on the same level, so we can write this as x plus square root of x squared plus 1 divided by the square root of x squared plus 1 times x plus square root of x squared plus 1. And you can see that square root of x squared plus 1 plus x in the numerator and similarly in the denominator cancel, and we're left with a nice simple version of du, which is 1 divided by the square root of x squared plus 1 times dx. And now we can return to integration. We started with the integral of natural log of x plus square root of x squared plus 1. That was our integral of u dv. It's equal to u times v, which is x, times the natural log of x plus square root of x squared plus 1 minus the integral of v times du, which is x divided by square root of x squared plus 1. And notice that the integral on the right is much easier. To finish the problem, all we have to do is integrate x divided by square root of x squared plus 1. So let's do that. The integral of x over square root of x squared plus 1. You can see that it's clearly done by substitution. We'll let w equal to x squared plus 1. dw is equal to 2x dx. So 1/2 dw equals x dx. And so the integral becomes, in the numerator we have x dx, which is now 1/2 dw, and in the denominator we have w under the radical, so square root of w. This is 1/2 times the integral of w to the minus 1/2 dw, which is 1/2 w to the 1/2 over 1/2, which is w to the 1/2, or square root of w. And using variable x, that's just the square root of x squared plus 1. So to summarize, the integral we wanted to evaluate, the integral of natural log of x plus the square root of x squared plus 1, is equal to x times the natural log of x plus square root of x squared plus 1 minus the integral of x divided by the square root of x squared plus 1, which is equal to x times the natural log of x plus the square root of x squared plus 1 minus the second integral, which we just evaluated, and that was square root of x squared plus 1. Then we can add a constant c at the end. For more videos,